Today's demo is going to be a AI code reviewer agent. It's going to be a GitHub repo that I'm going to open source, and there's a QR code at the end that you guys can scan to just take it away and start using it today. Essentially, what the repo is going to be, it's going to be a very simple Terraform deployment of a Civo virtual machine, right? So we mentioned one of the key components of a successful sandbox is hardware isolation. And so via GitHub Actions, the Terraform is going to provision a Civo Cloud virtual machine running on Civo's sovereign infrastructure. Within the virtual machine on start is going to be a bootstrap script that does a few things, one of which obviously install dependencies. The second of which is going to instantiate our sandbox. So it's going to set up our guardrails that we define for our sandbox, basically the slide that I presented previously, like egress policies, user groups, etc. But I'll go through that when I go over to the repo. The Bootstrap script is then going to run a Claude Code session. The Claude Code session is going to talk to relaxAI, which I'll come on to and run through a little bit more in a few minutes. But relaxAI is a secure UK sovereign AI provider. So you can be confident that the data that we're going to put into relaxAI is self-contained in UK soil and it's secure and it's not going across UK borders. But I'll come on to the details of which in a few minutes. So yeah, the Claude Code session talks to relaxAI. relaxAI gives a response. We've also give it a user prompt. Now, the repo is largely generic, so you can put in whatever user prompts you want. Like I said, today I'm going to be doing the code reviewer agent. So the user prompt is going to basically just be saying, you're a code reviewer agent. Here's a GitHub repo. Can you list all the open PRs? Can you understand the change? Can you understand the code base? And can you provide a comment, an approval, rejection, or make changes instruction to the person who's opened the PR and put that into the comments. This is going to scale really well. So if you have multiple open PRs, it's gonna do them all because it just iterates through them. And yeah, like I said, it links to your GitHub repository through your GitHub token. So you can plug in whatever repository you might have. I've just got a toy example of a dashboard that I've set up, but the key part is it's got a pull request. So that is the overall architecture of today's demo. I'm then going to flick over to the GitHub repo, which again I'll open source at the end of this, so you can scan away and take it and start to plug and play as you feel fit. So again, this is my personal GitHub, but it's called like Sandboxed VM. Obviously, clues in the name. And I'm not going to go too much into the code. There's not actually that much code anyway, but it's irrelevant for the purpose of the demo. But the key part of this README is here, i.e. what it does. So the relax sandbox VM repo will provision an ephemeral Civo VM that boots. It will run a bootstrap when it boots that instantiates the sandbox, like I said, but it also runs a single Claude Code session that points to the relaxAI API. It'll pass in a user prompt and the relaxAI will do the magic and kind of review all the pull requests and then give the response back to the stream where we kind of like log that response. We then SSH into that VM and we pull those logs and spit them out into GitHub Actions, right? So the flow would be provision the VM, run the Claude Code session that points to relax, review the PRs with comments, and then pull the logs back after SSH and into the VM and put them into the logs of GitHub Actions. We're also going to put a comment into the PR that's open as well, so we can go and see it. So yeah, the VM is a sandbox. It has one task, one VM, and zero persistence. It's going to spin up and self-destroy in a matter of minutes, which is the perfect property of a sandbox. So again, not going to dive too deep into the code because it's irrelevant and there's actually not that much of it. But essentially, like I said, we're spinning up a virtual machine. So we need to do things like create a public key to SSH into it. We need to create firewalls So we can kind of like have that zero trust egress policy around our sandbox. And we actually need to spin up the instance itself. We've got our SSH key, we've got our firewall. And if I scroll down to the important part, we've got our Civo instance. And like I said, when we spin up our Civo instance on line 77, we're passing in a script, and this startup.sh is our bootstrap that essentially runs this Claude Code session and creates this sandbox around our agent so it's kind of safe and secure. Notice all the parameters that we're passing into it. We're giving it the model, which in our case is going to be our Kimi K2.6 model, giving the base URL, etc. So again, this is just a bash script, which I'll let you guys read in your own time because I'm not going to be presenting bash on the call, but lines 4 to 13 are the main bulk of what this does, right? So what does it do? Remember the slide that I gave you about what constitutes a good sandbox. So it installs dependencies, obviously. It then creates an unprivileged user called agent with no sudo access and no group membership. So we're giving the agent only permissions that is absolutely required. It caps the agent's process count. It shreds Cloud init artifacts to prevent the agent from seeing any secrets that it doesn't need to. It creates our egress policies. It runs a single Claude Code session as that Linux user that we set up against the relaxAI API. And then what it'll do is stream the output of the agent session back into the logs or back into the logs inside the VM. So we've got our startup script, we've got our sandbox created, we've got our Claude Code session. The only thing that we need is a user prompt to actually tell the agent what to do. And like I said, it's going to be really simple. We're basically telling the agent that it needs to be an autonomous pull request review agent, review every PR in the GitHub repository I'm going to give you, and look at these environment variables, basically. So you give it your target repo, you give it your token for your GitHub, mine's my personal account, and whether you want it to do a dry run, I'm going to set this to 0. I don't want it to do a dry run. I want it to actually post the comments in the comments of the PR because I'm demoing it today. So the workflow is going to be like list all the open PRs in your repo, create a diff, so you get a kind of like really good context of what the change is going to involve, and then give your verdicts essentially. So do I approve it? Do I request changes? Or do I comment? What the summary of the changes and some notes that will help the human involved when he comes to reviewing and merging the changes. So the final part of this repo is just going to be kind of like the GitHub Actions step. This is just so you can run it really easily in a CI. You don't have to worry about any kind of like Terraform deployments locally or anything. So essentially, it's just going to be 4 steps. It's going to be Terraform init, plan, and apply. I'm going to provision the infrastructure. And then in this stream agent log step, I'm pulling the details of the VM. So IP, SSH details, and SSH into the instance. And then I'm going to pull these logs that the agent's giving out and stream them back into GitHub Actions. And if this doesn't make sense, like we'll look at GitHub Actions and see the response of the agent in just a second. Like, you don't need to read any of this. But yeah, like I said, it's all done through GitHub Actions. So if I flick to my only deployment in this repo, I can start to run a workflow. Click that, give it a run. Now, what it's going to do, like I said, it's going to do things like initialize Terraform and apply it. So it's going to spin up a firewall and a virtual machine, and then it's going to run that bootstrap. So it's going to take a few minutes to get up and running. Like I mentioned before, one of the key characteristics of a successful sandbox on top of the criteria that I mentioned is this kind of like fast boot time. Now, that's only relevant if you have the need for like largely ephemeral workflows. But what we're seeing quite a lot of the time is these long horizon research loops where the boot time of the kind of like sandbox is mostly irrelevant because as a proportion of the entire research lifecycle, it's relatively negligible. So This VM is going to take a couple of minutes to launch. At the end, I'll go on to discuss like a fully managed solution that can actually spin up a sandbox very, very quickly. But if you want to kind of like plug and play today and just spin up a VM for a couple of minutes, this is perfectly fine. So I'm going to leave that running. I'm going to switch back to the slides, and I'm just going to like touch a bit on like what relaxAI is, if you guys haven't heard of it before, and kind of like what the problem is we're trying to solve. So obviously we talked a lot about the importance of building this kind of environment around our agent, right? We've said like what a successful sandbox looks like and the importance of putting your agent in a sandbox. But the only missing piece is the kind of like due diligence and care a user must have around the LLM provider that they use, right? And suppose you're running kind of like agentic research in a heavily regulated industry, you need to be very careful about not just the sandbox where your agent runs, but the data that you're putting into your AI provider's API. That data might go across borders, it might be used for future model training, etc. And so this brings us on to kind of like why we built relaxAI, and the purpose we kind of trying to achieve here. So relaxAI is a fully sovereign AI provider that runs solely on Civo's UK inference infrastructure. So full UK data sovereignty end to end. We host frontier open source models. So really excited with the recent releases of our DeepSeek V4 Pro model and Kimi K2.6. Building on the topic of agentic AI, these are some of the most advanced open source models out there for long horizon agentic loops. Very predictable pricing and actually quite low cost. So mentioned DeepSeek V4 Pro again. If you were to switch from the likes of Opus to DeepSeek V4 Pro, you would see a substantial drop in token pricing for a relatively trivial drop in performance. So because the open source community is starting to reach parity with the closed source community, it's no longer the case that when you switch to open source models, you're going to see a drop in performance in your workflows. And so you as a user need to realize, can I cope with that very small negligible performance drop for that significant price reduction? And finally, we have kind of like this agentic at its core mindset. So we specialize in kind of like these agentic workflows. And our model offering obviously reflects that. So a bit more about what the key components of relaxAI is. Obviously, we're building this out quite a lot into more of a platform. So it's quite hard to split it into 4 distinct groups anymore, but I'll try and do my best. So one distinct group is the inference. relaxAI, like I mentioned, hosts some frontier open source models like DeepSeek V4 and Kimi K2.6. They really excel at these long horizon reasoning tasks, utilizing things like long context, over 1 million tokens in context, etc. All for up to 80% cost reduction on your token bill. So the migration process from a Claude Opus to a DeepSeek or Kimi on the relaxAI API would bring significant token cost reduction, and the actual process of that migration is just a 2-line code change, and you're up and running. The second key component is a dashboard, so really clear layout and simple to navigate. We're really excited to be releasing another iteration of our dashboard very soon, and our entire kind of like Relax platform, so stay tuned for that. But the dashboard has things like built-in deep research, bulk document analysis if that's what you're doing. But the key part is very predictable billing with no hidden costs as well. The third part is the API. So the API is very flexible, reliable, clear documentation. I'll leave a link at the end to go to our documentation, check it out. But with regards to the API, we built it with one-to-one compatibility with the OpenAI API in mind. So talking about the migration process from your providers of the minute again, that process is seamless, and just a two-line code change in your .m file will get you up and running in just a matter of minutes. But if APIs aren't your thing, we have a lot of relaxAI SDKs as well in Python, TypeScript, and Go, so that can kind of like plug into whatever your stack involves right now. And the final one of which, obviously, we're using Claude Code in this instance, but actually Relax plugs into many integrations, over 30 that we have documented, but they can power anything from drag and drop workflows to autonomous coding agents like we're kind of talking about today. So I'm just going to flick back to the pipeline and show you kind of like hopefully what the agent has done. First of all, the repo that I'm actually pointing at here is this repo that I've designed in like 5 minutes. It doesn't really matter what it is. This could be your team's repo. It could be your personal project, for example. But the key part is it's got an open pull request here. And so if I flick back to GitHub Actions just to get a bit of exposure of what the agent is doing and what the workflow looks like, you can see each step quite easily, right? So ephemeral SSH key to be able to exec into the VM and pull the logs. All the Terraform deployments, so Terraform init, Terraform apply. This is going to spin up the VM, firewall, etc. But the key part here is, like I said, this is the bootstrap that's actually running when the VM launches. It's going to do things like instantiate the sandbox with those key criteria that we laid out on one of the earlier slides. And then it's going to use my GitHub API key /token to pull all the open PRs. In this case, it's just one. It's going to review the PR, and then it's going to post a comment to the PR about whether it's going to be approved or not. And you can see the chain of thought of the agent here, right? And you can see the response that it's given and why it's made that. So I requested changes to the chart.ditch area. So this time it's actually requested changes. And if the logs of a GitHub Actions isn't your thing, which likewise, you can head over to the open pull request in that repo, and hopefully you can see the agent has dropped a comment 4 minutes ago, requested changes to my team member or me for this pull request, right? So explaining why in a lot of detail. It's got full context of this repository and what's going into it. And so it kind of takes the burden off whatever kind of like the staff engineer, or it might give a bit of a helping hand into the review process. Obviously, this only has one pull request, but this scales to however many pull requests you might have. You got to remember the models like DeepSeek and Kimi have really long context and the ability to maintain accuracy at long context as well. So if you have a really large code base, it can comprehend that and store that in memory really well. So it can start to act as a bit of a staff engineer.